Today, the topic is really about AWS Route 53 and DNS. So just the pretty much like if we want to look back at where we're coming from, I think we've touched so many things, right? Storage, compute, we've even now touched networking, right? So ideally in an AWS environment, all the things we've seen, especially the ones that could be within a VPC, you put them in your own private network, right? But that's always not the end of the world. At some point, you need your website or your application to be available, right? To be seen from the outside world. And because everything we've been seeing so far, sometimes we've been testing things that are in AWS, right? And it's not just being seen from the outside world, it's also seen with a fancy name, right? So when you go to TikTok.com, it's obviously different from if you had to type like TikTok's IP address to get there, right? Because many of the times when we launch an EC2 instance, we usually go to the console, copy the IP address, paste it in the browser, right? But in the ideal world, whatever is there, you're going to have like a URL for it. Maybe call it TikTok.com, give someone TikTok.com, they'll go to a browser, push it there, and then it's going to open the TikTok app, right? Something is beneath servicing the request. So up until this point, I think we've been dealing with some of the things that are beneath, right? Maybe the compute or the storage that is servicing it. And now we're just looking at how do we expose it to the public, right? Which is what we're going to be talking about today. And that brings us to AWS Route 53. But again, like with everything cloud that I've mentioned before, Route 53 is an AWS service to do DNS management, right? But DNS itself is not native to AWS cloud. If you were on-premise traditional, you will know DNS. If you are in any of the cloud provider, you know DNS. The point is that many of these things, I think we've said it over and over again, that it's not like the cloud is reinventing it. The cloud is just helping you make it easy for you to manage it, right? That's just the difference. So in this class, we'll learn basically some DNS fundamentals and how Route 53, which is now a DNS in the AWS cloud, helps to make that easy. We'll look at the DNS record types, the types that we have. We'll look at Route 3 routing policies, right, that you can use to manage traffic. We'll see health checks and automated failover, the options that we have, domain registration, hosted zones, and some things around DNS optimization and cost. Okay, so let's now talk about DNS. Like, what is DNS? Is popularly called domain name service, right? And it's simple. The work of DNS is basically simple. It just translates your domain names to IP addresses, right? If you remember every resource that we deal with, whether it's EC2 instance, when there's usually like a unique IP address, right? So think about it that like when we did our Hello World EC2 application, it was behind an IP address. We had to go to the browser, type the IP address. But in the real world, you don't want to be sending your IP address to someone to use to access that application, right? In the ideal world, you send the person my sweet web application.com. You send that to the person, and then that's going to resolve to the EC2 instance, right? But there has to be a way to do that, and that's what DNS does, right? It translates names, my sweetwebsite.com. It translates it to an IP address. So the point is that TikTok.com, there is an IP address powering TikTok.com behind the scene. Every website that is out there, there is like something behind the scene that is powering it, right? Yeah, obviously hierarchical, right? Because you have top level domains, root domains. As time goes on, we'll obviously explain what that means, right? But the whole idea is that it's like a naming system that you have to follow. There is like a convention. So when you think about when you think about the samplewebsite.com example that I gave, you on your browser, whether it's on your local machine or your browser, you type samplewebsite.com, it's going to call a resolver. So something is going to resolve it, right? Your ISP, your network is going to resolve it. And then it goes to like a root domain that will resolve it to maybe like a top level domain. We'll see a diagram that depicts this very well, right? And then it goes to somewhere that knows what is example.com, what translates to example.com, right? And because at the end of the day, example.com is backed by something. But when it gets to the authoritative destination that it knows that example.com will be resolved from this IP address or from this EC2 instance, for example. Okay. Obviously, there's caching that you can do to improve your performance. We'll see what that is, and then time to leave, which can help you control the cache duration, right? And then forward versus reverse DNS lookups and the applications, because these are some of the things that we are going to see that makes up a complete DNS. Okay, so when you now want to say how does it really work, there is like a blog post. It's not very clever. When you get the notes, you see it here. It's really a link that links you to AWS that is trying to tell you exactly how DNS works, and I think I've explained it. But I think if you go back to this diagram, it becomes clearer. So you would enter example.com. It could be any website that you love. There is really a resolver that receives that request, right? And begins to look up. The question is really, it will be trying to find who is example.com, where is example.com located, right? So the first thing to do is to query the root. The root is the .domain, and ask it, where can I find .com? And then .com will be like, okay, the dot will be like, I don't know, but I know how I can get you to .com, right? And then that takes you to basically where .com is like the top level domain where .com is can be resolved. And .com can also tell you, oh, I don't know .com, but I know example.com, right? And that will now take you to wherever you got your domain from. So this diagram just depicts, you don't see that behind the scene, but really every time you go to tiktok.com, this happens, right? And sometimes your resolver, which is happening in your local machine, will it will more or less like cache the website such that it knows how to resolve it. Obviously respecting the TTL, time to live, right? But again, one thing you notice is that once it knows where example.com, the next thing it's going to do is that it's basically now going to tell you, especially going to where you're hosted. And when you get there, the example.com will tell you, or whatever DNS routing you have, the example.com will tell you where are you going to go next. Maybe you want to pick an IP address, or you want to pick a Lambda function, or you want to pick an ALB, whatever the case may be, right? But at the end of the day, it resolves to an IP address at the end of the day that will be sent to the user, because it's only an IP address that can actually help you get a unique resource, right, over the internet, right? But sometimes we mask that behind a DNS name, okay? And then once that request comes back, the browser will basically take that IP address and just call the request that is behind it, right? So send request directly to the web server at that physical IP address, because the IP itself is the unique name, right? The DNS the DNS, the domain name is also unique, but what I mean is that IP address is what uniquely identifies what is behind the domain name. Okay, and you as we progress, it will all make sense. Okay, and then user sees the web page in the browser. So whatever was returned from the IP address that is behind the DNS name. Okay. So when you look at it, everything that I said is in this diagram. You start at the root. The root is dots. And from there, you go to your top TLDs, right? Your top level domains. So if it's a .com, it will go to like the .com domain to try to resolve where am I going to go next, right? Then if it goes to example.com, it's going to be asking example.com, how can I get to this service, right? And then from there, you can basically get to where the service is hosted. But when you look at the structure, there's really roots, there is top level domains. There is also like the second level domains that you see there. And like the example.com is a second level domain. Then if you take that further, like cluster.example.com is a subdomain, right? And then you could have all that become like a fully qualified domain, right? And then there is like the concept of domain registrars, as we'll see, and then your hosting providers, because you can buy domain from somewhere and host it somewhere else. You can also be hosted somewhere else and buy domain from someone, right? You can buy domain from like GoDaddy, but be hosted in AWS, right? You see how easy all that is as we progress, okay? And there are obviously some other contents for you to see that is part of this slide. So when you now look at those records that we just talked about, so we're saying that a browser, like a name, a DNS name, for example, in this case, like a example.com is going to resolve to an IP address, right? But again, at the point of resolution is where we come to DNS types, DNS record types. So more or less like the records you have, and these are the popular ones. There are so many record types. There are a lot of record types out there, but these are the ones that you really need to know. Okay, there's really a record. A record basically maps to an IPv4 address. Okay, AAA maps to IPv6, and we'll see them. It's easy from an example, but it maps to an IPv6 address. A CNAME record will map one DNS name, like one domain name, to another domain. So domain to domain is CNAME. 4 A's are to IPv6, and A is basically directly to going to an IPv4 address. And then we'll see what Alias is. Alias is unique to AWS. Alias is unique to AWS. You see how it helps you map like a domain to an AWS resource. That's just the difference. Okay. The other ones, you can use them to do the things we've mentioned, like that I mentioned above. So IP address, mapping to an IP address, IPv4 or IPv6, or to another domain name, right? But there is also one that allows you to map directly to an AWS service, and that's what is called an alias, right? And then AWS resources obviously is like your ELB, your CloudFront, S3, you know, whatever you have hosted, many of the options that are hosted in your account. Okay. So what is now Route 53? Route 53 is now a DNS service. All right. So at the beginning, I was telling you about how DNS works, right? The fact that you really have a host name, right? So more or less like example.com, but behind it there's an IP address that has to respond, right? But you don't want the users to know your that to have to keep the IP address. Rather, they'll have like a fancy name. So now DNS management in the AWS cloud is now what you can do with Route 53. So it's a service. It's an AWS managed DNS web service, right? Just like we've seen database managed, and we've seen storage that is managed, and we've seen a lot of managed service in AWS. One of it is DNS. Okay. So it's also authoritative. We talked about the authoritative part, right? Where if you go to example.com, there's someone that knows what example.com points to, where the resource backing it is resides, right? So they have like a global network, and they can serve as an authoritative DNS service, right? For those kind of, for whatever domains that you have within your AWS infrastructure, right? But they also do domain name registration, which means is that you can also buy domain from them, right? The point is that you can buy domain from someone else and decide to host it somewhere else. And that's why we've talked about like the different kinds of record types, because you can basically map one domain that you bought from somewhere to a domain that you're hosted somewhere else. Okay, so health check and monitoring, we've seen that in a lot of the service, right? That's how you know the application that is hosted is healthy, it's doing well, right? Through the health check that you can configure and the monitoring that you can also have, right? It integrates with all AWS services, a lot of them. So there is like direct integration for you to, from Route 53, go to other services that you have. So pay per query pricing model, meaning many of the DNS queries that you're going to be using over time, those will cost you money. Okay, that's an overview. So what are some of all the features we've seen? Obviously, it's obviously Anycast, right? We've seen that before, where you have like a global Anycast network for you to do your DNS resolution, right? And it happens really, really fast. That's the whole idea. Automatic health checks and failover, we'll see what that does, right? How you can do multi-region or multi-location, more or less like rerouting, right? So you go one place, it's not healthy, you can get something that is somewhere else that is basically healthy. There is obviously at an advanced use case, you see traffic flow visual editor, so like an editor where you can actually draw your, what do you call it now, your traffic flow basically. Remember, traffic flow in this case is not in the context of application, right? It's in the context of DNS, right? So DNS resolution. But we'll see how Route 53 also makes that. There is like a tool, we probably won't touch it, but it's there. I'll show you what it looks like. Integration with AWS services, like I mentioned, DNS security extensions. You obviously can add security on top of DNS, as with everything AWS, right? Where we've seen encryption at rest or encryption in transit. Yes, there's also DNSSEC that you can apply. Private DNS, you can also use it. Remember everything I've been talking about? I've been telling you about the concept of going to a browser, but sometimes you also want to do private DNS resolution, which, yeah, you can have very private domains that are not on the internet at all, but your users within your corporate network can go to those private URLs to resolve internal resource, okay? And then API and CLI access for automation, obviously. So in AWS, there are really two types of zones. Okay, there is like public zone and there's private zone. We're going to see, especially we won't be able to talk about private zone, but just so you know, like I said, public is accessible over the internet, right? Private, no one can see it from the internet, right? If you type it on the browser, it's not going to resolve. It's something basically that is private to your infrastructure, and you've seen how we can do private setup, right? Whether you set up a VPC, it's private. If you have on-premise, you can connect your on-premise to your VPC, right? You create that connection, and then within that network, you can't resolve private hosted zones, right? But there is obviously the most popular option, which is the public hosted zone. So whatever, anything that is resolved over the internet, so right, so contains records for public domains. Basically, there has to be like a public domain that represents that hosted zone, right? And then we'll see that it becomes clearer with examples. And then obviously Route 53 will give you a name server once you have that configuration done at your own end. So there's also private hosted zone, basically internal to your VPC. So if you add something like internal.example.com, but it's not, no one can resolve it over the internet. Private resource, that's one example, right? Can span multiple VPCs and regions. And the reason why that is there is just the fact that I've told you, if you have one VPC, two VPC, you can create peering connections within them, right? And then a private route hosted zone can work, but you can also have like multiple VPCs connected to your on-prem, and for that reason, you can have you can set up the DNS resolution such that within that private network you can resolve private hosted zones. Okay. With that said, let's now think about some of the routing policy. So it would be nice to go through the class first, and then we'll just do all the practicals once, okay? So that I'm not context switching. But there's really the kinds of routing that you have. So the first one is simple routing. Simple routing is simple. Basically, one thing you need to take out from it is that no health checks. So simple doesn't do health check entirely, right? So single resource basically serves the DNS queries for the most part, right? It can have multiple IP addresses, right? So you can have one or more IP addresses, but the client will choose which one they want to basically send their request to. That's the simplest form, right? So you just create like a resource or a record, and you're backing it by one or more IP address, right? So every time the end user is calling that domain, you send him all the IP addresses that backs that domain, and the client gets to choose one of it, right? So they will choose. So it's a client-side load balancing, okay? And for simple routing, and you'll see from an example, okay? Use case, single web server or load balancer. So like you have like an EC2 machine you just wanted to expose on the internet. Why not? If you don't have any more, you don't have any complex requirements around how the routing should happen, you could just use like this very simple routing, right? There is also multi-value answer routing, right? So returns multiple healthy IP addresses. That's one thing you should take note of. It's more or less like it's similar. It's similar to what we also just discussed, right? Um, um, client side load balancing is also happening, right? Up to 8 records returned. But one thing you need to know is that the first one didn't really talk about health check, but here health check is involved, right? You need to have like health check for those URLs, right? So that if one of the endpoint is bad, or one of the records are bad, um, it will not be returned as part of the DNS record. Okay, so you have multiple IP address, but whenever you make query, because they are backed by health check, if that health check should fail, they're just going to be taken out of the records that are returned from the DNS query. Okay, so it differs from simple routing, and the reason is just because of that health checks that is included. Okay, so alternative to application load balancer for simple scenarios. So in case you wanted to still use the application load balancer scenario, you still can, especially if you have health check that you want to also be monitoring, right? As part of whatever you're doing. And then weighted. But again, one thing about AWS, I think I've already said it, is the simplicity in which they name things. I think they try. So if you think about it, we've just talked about simple. Returns multiple IP address. The client is going to choose which one to use, right? And we talked about multi-value, the fact that multiple IPs are returned, but they have to be healthy endpoints. So if one is not healthy, it's going to be taken away from whatever is returned, right? So it's not client-side load balance. The client will still get to choose which one to use, but the good thing is that those IP just know that it will always be healthy, right? Good. And there is also now weighted. If you wanted to, more or less like send weighted traffic, right? So basically route traffic based on assigned weights, more or less like the ones where there's more weight, traffic is moved to that direction, right? So the weights are usually between 0 to 255, and then you just take a percentage to know how much of the traffic is going either to any of the records that you have, right? So useful, maybe you want to do A/B testing and gradual deployment. I think we've seen this before, right? When we're doing global accelerator, you saw how we updated the weights. We're able to put one at 0, put the other one at 100, and then we completely just routed traffic to all the place to the load balancer that had a weight of 100. So I think the concept here is the same. It's just weighted. You push more weight, traffic is going to go there more, right? And you can also combine it with health checks. Just know that health check is just what informs Route 53 if that particular endpoint should be added as part of the DNS query. Okay, so if it's non-healthy, it's going to be taken away. That's just what health check is going to be doing for all the other ones that we will see, right? So you can see example is, you want to send 80% to your primary resource, and then maybe you want to send just 20% to your secondary resource. However you define that, is your thing, right? The calculation is simple. It's the weights and then plus divided by all of the weights, so times 100, right? I think that's how we do basic percentage calculation. You take something over all the total, and then you times that by 100, right? So then you assign weights, and then based on how high your weight is, you can get you can get more routing sent to you, right? Cool. Latency-based routing policy is also very straightforward, right? When you hear latency, you should know that we are talking about lowest latency, and latency is basically how fast are you getting the result. So what it means is that it's going to see it's obviously closer for you. So if you're going to, it's going to route you to the place where the result is going to be faster, right? And you've seen that for sometimes it's usually like related to your region, because if for me, if I'm in Canada, so if I was more or less like fetching data that is coming from the Canada region, it's going to be faster compared to if I was to fetch data from Africa or from Asia, right? Because there's going to be that distance, and that's remember we're talking about those physical data centers, they're far, right? So that's just what it means. So in this case, it's just more or less like we're saying, if it's closer to you, you'll be routed to the region that would make the result get to you faster, right? And then the whole idea is now, if you wanted to go beyond the simple or the weighted, and you wanted to really care about where the user is connecting from, and which of the application will give them the best user experience, right? So you can combine obviously with health checks for extra failover also, as we'll see. Obviously, like I said, if you're going to be doing latency, you obviously need multiple regions. I think we've also, even when we're looking at global accelerator, it won't make sense if you're accelerating within one region, right? You have to really give different regions for it to make sense, because you're doing more or less like a globally available service. It's the same way here, where you're trying to do latency based on where your users are connecting from. Maybe you have like three sites. Maybe there is like EU, maybe there's like the US, and maybe there's Africa, for example. And then you can have these three endpoints, and then depending on which one is closest to you, you are sent there, right? But they are all powered by the same maybe back end, right? The same application. It's just to enhance the user experience, right? And then there's obviously the failover routing policy, which is active passive failover, right? I think we saw this a bit when we're doing RDS, where you could have like a standby. So you create the primary resource to handle your traffic. It's obviously going to be doing it when healthy. And then if it fails, there is like a backup that traffic is sent to, right? So you can see how that concept, because we know that even if you're hearing this, if you're hearing this for the first time, you should be able to gauge and say, okay, failover, I've seen what failover is. Usually there's like a primary, there is like a secondary. All the traffic will continue to go to the primary. And then if the primary anything goes wrong, right? Remember, at the back of it, it could be a machine, it could be a load balancer, anything can go wrong. Maybe it was terminated, maybe something happened. The DNS is Route 53 is smart enough to send it to the passive, endpoint, right? Requires health checks basically. So health check has to be if the primary is wild and we want to know when it's healthy, that's when we send traffic. And when it's not healthy, we don't send. Then we need to have health check assigned to it, right? For us to know where to go when things are not working as expected, right? So automatic failover and failback. Obviously, we will use that for disaster recovery, right? So you want a situation if one place goes down, my workload should still be able to continue. Okay, we'll see them. We'll see these things. They're all in the same place, so it's easy for you to see when the time comes. So we've talked about like four of them, but from the name, it's easy to remember and understand. And geolocation, if you know location, right? Just think about it, location. So it's just based on where are you located. That's how the traffic routing works, right? So you can route traffic based on where someone is located, right? So and you can break the granularity up to the point of continent or even country or like a particular US state, right? To route traffic based on where the person is connecting from. Useful for compliance and localization. Yeah, we've seen compliance sometimes when you want everything to happen within a particular place, right? So everything should just happen within a region. So if I'm already in EU and there's already an endpoint in EU, maybe a routing policy in this case will be if you are in EU, be serviced by the endpoint in EU, right? Which is also hosted in EU. So that's a good way for you to do compliance, right? And even localization, because yeah, across boundaries, we know there are different languages, right? Obviously, you can do language, currency, those kind of things, right? If you especially if you're dealing with maybe your own country, for example, we know that in some places they speak different language, right? Just the reason for you to expose the endpoint that is there, right? Because of it has all these features already. Data sovereignty, keep data in one place, right? And there is obviously like a default location. If you couldn't obviously get any of the it couldn't route you to any of the continents, right? There is a default location you can pretty much go to also. Any of the granularity that you chose. So if the person doesn't fall within any of those, you basically can pick a default location to go to. Okay. That brings us to proximity. So when you think about geoproximity, we've just talked about location, right? Where the user, right? The user now is based, right? So where am I connecting from? And then I'm routed to whatever has been specified for that my own region or country, right? But when you look at proximity, it's really about geographical location of the resources, right? So you're not talking from the user's perspective again. Rather, you're thinking about proximity to where the resource is, right? Um, so it's still a combination, but in a lot of cases here, you're really looking at where is the resource, where is the resource base, right? And then one thing you can do at this point is that you can use bias to more or less like expand or shrink, right? So ideally, if a user is closer to a place, it will go to the resource that is closer to, right? But you can also use bias to more or less like extend that or shrink it. So that's what I meant. You can expand and you can also shrink if someone will go to. So if I'm meant to go to like US West because that's a resource that is close to me, I can use a bias to alter that, right? To make sure that okay, maybe some part of people who are in US West too still can go to the other parts. You can have the range between -99 to +99. I think those are just lower level details that you see from like a pretty much good example, right? So positive bias, more traffic. Negative bias, obviously, less traffic, right? And it's just the same way as adding weight. And we just know that in this case, it's not looking at proximity, right? The other one we talked about where you could do weighted routing and just use the weight to control where more routing is going and where less traffic is going. And the same way here, you can have geoproximity and then you can have bias on top of that to control where you push more traffic and where you push less traffic, right? There is also a visual traffic flow that you can use to model what you want to have, but obviously that's advanced. It's more sophisticated than geolocation, right? We'll see it. It's more complicated actually. But because geolocation just gives you the ability to choose like a continent, country, you see how it differs. Before we go into health checks, because we know exactly what it is, like we know what a health check it is. So it's a good segue for us to go into the UI to see some of these things. They make more sense when you go, when you're actually in the UI, you begin to see what. Okay, so let's look at the Route 53 service, which is a managed DNS service from AWS. As you can see here, it says Amazon Route 53, reliable way to route users to internet applications, right? So one thing you take note of is that there is really you can also use Route 53 to do your domain, like to register your domains, right? So which is really where most people will start. So if you go here, I already have something open. You basically, if you go to register domain and you want to register a new domain, you search for the domain that you want to register. You search for it. If it's available, you select it. You proceed to checkout. Whatever this is, it's going to come out from your billing, right? There is room for you to set auto renewal, and then you see the price, right? And then if you click on next, that is actually going to take you to a page where you can pre-populate your information, whatever information you have, and then you do next, and that will give you a domain. Okay. I won't be registering domain on this call because I have some domain that I want to test with. But one of the things I really want to show you is that once you create a domain, whether it's AWS that you created that domain, whether it's from Route 53 or from a different host, from a different domain provider, the most important thing that you need to know is that I think when you create a domain in AWS, it's to create a public hosted zone. But just so you know, most times a domain can exist outside of AWS. It can be in AWS and can also be outside. The most important thing is that once you have your domain, you just need to point the name servers to a record where you're hosted, right? In this case, we'll look at AWS as where we want to host our service, right? Here, it created, normally when you have a domain, you can create a hosted zone, but I've already deleted the hosted zone that came with it. So I'm going to create a new one, right? So I'm going to create a hosted zone and call it, so if I look at the domains that I have, if I do leave and go to like domains, I have this Brino.cloud domain. So that's the one I'm just going to do. So I'm just going to do Brino.cloud as my public. Remember, this in this case is my public hosted zone. So Brino.cloud is my public hosted zone. I'll say the public hosted zone for Brino.cloud, right? So that's what I want to do. Yeah, it's public in this case. I'm just going to do create hosted zone, right? So the most important thing here is the fact that there is a record, which is like a name server record that is given to us. So this is now what I need to link to my domain, right? So I would link this to my domain, whether it's in AWS or it's in a different account. And that's where I do like the connection to make Route 53 my authoritative answer for that domain, right? So in this case, I just need to push this to my domain name, right? So I'm going to go to my registered domains, and then I'm just going to update this record for my, I'm going to push this record to my actual domain, okay? So which is what I'm going to do. Okay, so what I've done behind the scene, because although it does have some of my personal information, so what I've done behind the scene is to copy these to my domain name and make it like the name servers, okay? Every domain name that you have, there is a place where you can adjust the name servers, meaning who is going to answer when this domain is called. In this case, it's Route 53, right? So we want Brainyville Cloud, and ideally, this is not going to be useful to us unless there is something behind it, right? We looked at all the routing policies and rules, and the only way you can make sense of them is if you begin to create record. But this record needs a place to go, right? So which is what we need to do. So we'll go and create some EC2 instances. So I'm going to go here. I'll go to EC2. I'm just going to close the tabs to the right. I'm going to close this one. So EC2 instance, I'm going to launch first one here. I'll call it US West West 2 web server, right? Just to show that it's in the UE. So these are basic stuff. Linux 2023 T3 micro. I don't need to keep here because I don't need to SSH. But I basically need to allow traffic from the internet. I won't need SSH, but I need access. And here is where I'm just going to paste a simple user data script. It could be any of these user data script that you know of that you've used. It's just basically, but in this case, it's actually going to echo out the EC2 region, right? And echo the region name. So I've seen all that in US West, so I'm just going to launch. I'm going to launch it, right? While that is launching, I'm going to go to EU Central 1. So I'm going to go to EU Central, which is Frankfurt, right? So EU Central 1, and then I'm going to launch another EC2 instance. So I'll go here. I would say my web server EU Central, Central 1. Let me just use this, right? Same basic stuff. So I'm going to proceed without a keep here. I'm going to allow traffic from the internet. I really don't need SSH access. For advanced, I'm just going to paste my user data script, right? So I'm going to launch the instance. It's going to launch in a public subnet, so we will have like a public IP address, okay? So that is launching, right? So I'm going to leave this on one end and then try to open my second region on the other end, right? So we'll look at the instances launching. So I'm going to go to instance here, and I'm going to click. So what I'll take note is I'm just going to take this. So this is the one in Europe, right? So I'm going to go here and say EU Central, right? I don't even need the caps, so I'm just going to do EU Central. I'm just going to map it, right, so that I know which IP address. This is the public IP address, right? The one that is here. Similarly for EU West 2, I'm going to take note of the public IP address. 34 is 34 dot, what do you call it? So I'm just going to go to my sticky notes and do EU West 2, right? No, sorry, US West 2, and I'm just going to paste the IP address, right? So it's here. Now with IP address pasted, meaning we have two instance, and ideally it's good you test those EC2 instance. So just to make sure that whatever you have, right, is working. So I'm just going to do HTTP colon and then paste this IP address. I think I didn't do that very well. So do this and then paste it. Yeah, so this one is working, right? Cool. So EU US West 2 is working. Let's test EU Central, right? So I'm just gonna paste this one. So cool. We have two EC2 instances that are already running, right? So one is EU West 2 and EU West 1. So the first thing we basically need to do is first of all, so we already have a record. The question is that is there anything behind this record? Right now there is none, right? We only have like the root hosted zone. So the thing we could create a simple record, right? So in this case, where do you want the record to be? Should it be at the host, like at the top the apex zone? One thing we can do is to say that let's start with simple routing. And what we're just going to do is that we will start a simple routing and say TikTok.brainhill.cloud, right? So in this case, it's a simple IP address. So we're just going to do simple routing. So we're just going to go to EU West. So we'll go here, we'll paste that one in, and then we'll pick the second one. Remember, simple routing, you can have multiple IP addresses, right? Listening to your, so we have that, it's simple routing. I'm just going to set the TTL to 60 seconds, and then I'm going to create records, right? So this record is created, and we have EU West 2 here, EU Central 1. So what do you think is going to happen when we go to TikTok, talk .brainhill.cloud? What do you think is going to happen? Yeah, so it did take us to EU Central 1. So you can see immediately from just setting up the EC2 instance, we're already there, right? But we can also verify what's really happening behind the scene. So I'm going to go to EU Central, EU. I'm going to do Cloud Shell, right? So I'm going to do Cloud Shell, and then I'll click on Cloud Shell. For Cloud Shell, I'm going to do dig on this domain name that we have here, right? So I'm going to do a dig command, right? So I'm going to do dig, TikTok, right? TikTok.brainhill.cloud, right? So I'm going to do this. Dig is not installed. Obviously, it's not a command. So I need to install the, what do you call it? The dig util. So I have the command handy just to install bind utils. That is going to install and get us the command that we need. Let me just make this a bit large. So I'm just going to do large here. So it's asking me if I need to confirm it. I'll do yes, and it's going to install. Now it's done. Let's rerun that command. So we did dig, and one thing you notice is that it gives us an A record, right? It's pointing to an IP address. It did give us two IP addresses. So if you see them, they actually correspond with these ones, right? And the time to leave, if I try again, this basically how long it needs to take before it queries the server again, right? So like a TTL. In this case, we're basically doing, so what really happens here when I go to this URL is doing client-side load balancing, right? So it just chooses any of those two IP addresses that comes in. There is really no extra logic, right? So that's really simple routing. So it's the client that will decide which of the IP address to open. So in this case, I think it's just giving us EU Central for the most part. And that is not changing, right? So the next thing we can look at is that one thing you also notice is that if we go back to the record, for example, so yeah, that's really, so if you look at that, that's simple routing, right? But we could do more advanced routing, like we saw from the class. We could do many other kind of routing. And one other one that we can do is we can do more or less like a multi-value, right? But again, like you've seen, multi-value from what I mentioned when I was talking about it in the slide, multi-value makes a lot of sense during health check, because the problem with this one right now is that If any of these ones, because it's not backed by an health check, if any of them, if something goes wrong, you really won't know. The client will still be seeing these IP addresses, and when they try to open it, something might go wrong, right? Um, which is something we can do with health check. So, for example, we're already currently tied to EU Central One. So, what do you think is going to happen if we go to that EU Central One, and then we go to the security group, for example? So, this is EU Central One. We go to Launch Wizard, and then we just edit the inbound rule. We pretty much delete this rule, right? So, what it means is that no one again should. Yeah, it's more or less like we can't gain connection again, right? So that's what happened. And so if we refresh, it will be stuck here. The problem is now you can't really get the instance again. But the client is also not smart enough to know that that instance is bad, right? It keeps giving us as part of the result, right? Which is something we can solve with some some more optimized routing in this case. So how do we fix that? So what we can do is now we can actually go here in the Route 53 and go to health check. So we'll go to health checks. We will create one health check. We'll create an health check. So we'll create an health check. And then this health check will basically do more or less like it's going to do. It's just going to do. So let's call it EU Central endpoint, right? So let's call it a health check that is there. So we'll do this, right? So it's an endpoint, it's an IP address, HTTP. We're just going to paste the IP address for EU Central. So EU Central is basically here, right? So we're just going to do this one. Sorry, I think I pasted the wrong thing. But let me just get the right IP address. I think it's this one. We'll copy it. And then we'll paste it here, port 80, and then slash, right? That's really the path. In this case, standard, 30 seconds. Maybe I want it fast just for this testing, right? I can leave everything, unchecked just to make sure that the health check is evaluating fast. I'll just create the health check, right? Remember, it's targeting the EC2 instance, right? I'm going to create a health check. And port 80, dash star, and then we'll create it. So the health check has been created. But again, even with the health check created, right? We'll just give it time. Basically, immediately it started failing, right? The question is that even with the health check, did this change? This is still not changing, right? This is still not changing. We do have a health check, but it's still not being used. So what it means is that even if I go here and I do a dig, I'm still getting the two IP addresses, right? So, which is one thing we can solve using a multi-value answer. So let's see how we can solve that. Because in this case, although this is EU West, it has switched to EU West now, EU West 2, but honestly, this is just load balancing. It's not because it was taking note of the health check, right? It's just this one. Because how you know is that if we do these, for example, it still keeps showing us the IP address. And that's why sometimes if you load this, if you're unlucky, it will try to take you to EU Central one, and then that's going to fail. So how can we fix that from a DNS perspective? So what we are going to do is that we're going to create a new one. In this case, we'll go to the hosted zone, and we will create a new hosted zone. So if we go here, we'll create a new hosted zone. So we'll just do this one, create this. We'll call it TikTok 1. So TikTok 1, right? So brainy.cloud. In this case, it's going to be more or less like, so we'll put the first IP address. So EU West is the first one. So we're going to paste that here. This is an IP. We just need an IP address. So we'll do this. We'll make this TTP, the TTL a bit short. We'll make it a multi-value answer, right? So what it means is that, and then we'll call this one. I just want to be sure which of them is this. So 213 is actually US West 2, right? So let's just be sure. It's US West 2, cool. So we'll just call this one US West 2, right? And then we'll add another record. So we'll also call it TikTok 1, right? The brainy.cloud. It's also a multi-value answer, right? And then we're just going to paste the second URL, the second IP address. In this case, is this one. So we'll paste this one here, and then we'll shorten the TTL, and then we'll call it EU Central, right? But this one is going to use a health check. So what we're going to do is that we're going to give this one a health check because we know this is for the EU instance, right? So with that, we're going to create the record. So we have two records, right? Well, this first one is just there is a bad EC2 instance behind this one, but for the TikTok one, there is really health check enabled, right? So what it means is that if we go back to our command and we do dig and we go to TikTok one instead of brainy.cloud, you'll see the difference. The difference is that this is going to return only one IP address, right? This one would always, so the first one, this would always return 2, and the client will choose 1. But because the second one is powered by a health check, it's not going to return the unhealthy host, right? So what it means is that it's always going to return this. And 213 is always the one that is in US West, the US West 2, right? So if we go back to TikTok 1, it won't even bring the other one as an option. It's just going to always load US West 2, right? So it's always going to load it, right? Because it knows. But the thing is that what if we go back and resolve our health check? So we go to EC2 instances, the one in EU Central. So we'll just edit the load balance and the security group again, and we'll say we want HTTP, or we'll just say we want, yeah, basically we want HTTP from everywhere, right? So that's really what we want. We want for now anywhere IPv4, we'll save the rules, right? So what it means is that with that saved, let's see what happens with our health check. So if we go back to our health check, um, we'll just go back to our health checks. We'll go to this one. We'll check the health checkers to see what's happening. We'll just give it time, right? Remember, before now, only one IP address is always going to show for TikTok one, .brainy.cloud. So when we do this, it's still one IP address. So let's just give this some time to see. Yeah, so it's now back to status code 200, right? So what it means is that if we try that TikTok one again, we should now have, I think there's a TTL. We just need to wait. But if we keep, count, once we count down with the TTL, let's give it some time. After a while, we will see, and this is really how TTL works, right? Things have changed behind the scene, but not until the next change, we are not going to see it, right? So let's give it some time, and then we would refresh. The next time we get a valid answer from the DNS service, we're going to get one that has that has more IP addresses now, because it's now considered as healthy, right? So it can be part of the pool. So we're just going to do that and wait. I'm just trying to see it, catch it live, right? So 4, we're counting down, Yeah, so it has refreshed, and now we have like the 2 IP address showing up, right? So that's we've seen 2, and so we've seen 2 records, 2 record type. We won't go through all the record type, but I think I should be able to show you one more record type. So if we go back to this Brilliant.cloud, we can also create a new record, right? And call this one TikTok 3.brilliant.cloud, and I think we do have TikTok. This is going to be 2. We have 1, right? So the next one we want to try is to do TTL is 60 minutes. So here we'll copy, we'll just go to the EU West 2. We're going to do this one and go back there, right? And paste it here. So in this case, what we're going to call it is that we're going to call it a geolocation, right? So more or less like the location the person is. In this case, we are doing, here we're just going to do location is, what do you call it? Let's say United States. So because yes, US, US, United States, right? So we'll do United States for this one. Here we'll just call it, we are really not using health check, right? But we know what health check is. We're just going to call this one US West 2 endpoint, right? And I need to just make sure I'm verifying that 213 actually ties to US West 2. Cool. So this is US West 2, right? So we're going to add another record and say it's actually TikTok 2. So TikTok 2, right? Brilliant.cloud. And in this case, we're going to paste the second IP address, which is the EU Central one. So we're going to paste this one, right? So it's here. And the type of routing is basically location, right? So location, TTL will be 60. We're going to call this one Europe, right? So we're doing Europe here. Maybe here we're actually doing North America, right? So just to be clear, so we're doing North America. We're going to call this one EU Central endpoint, right? So we're going to call it this one. So with that done, what we can now do is that, so just to be sure, it's TikTok 2, right? Okay, so it's shared, and then we'll create the record. So we now have TikTok 2 created, right? So with that, what we can basically do is to now see where is TikTok 2 going to send me to. So if I do, for example, I do dig TikTok 2, TikTok 2, like this. You can see it gives me just one IP address, right? And the reason is because I think it's answering from the, what do you call it? It's answering from the US West 2 region. Yeah, because that's actually where I'm there. But it becomes even more clear if we try it from the UI. So if I do TikTok 2, right? So I go here and I do TikTok 2, right? What would happen is that, yeah, it takes me and it brings me to EU West. So I'll always stay in this region, right? Because yeah, that's where I'm located. I'm located here. But what happens if I change my location to Frankfurt, right? So let's connect to Frankfurt and see what we get. So it's connecting. I'm connected, and then I'm just going to go back and try to refresh this, right? Yeah, automatically it took me to EU Central immediately, right? So you can see how that's switching. I'll continue to stay here. If I disconnect again from my VPN, after a while, it's going to take me back to my default region, right? Which is EU West 2. Okay. There are many more records we can see, but I don't think we can go through all of them. Okay. So I'm just going to delete all these records, these ones that we created. I'm going to delete them. I'm going to delete the records, delete them. Even the hosted zone, I'm going to get rid of it. So I'm just going to go to hosted zone. I'm going to delete it. I don't need it for now. So I'm going to delete it. Also, health checks, obviously, they will keep checking, so you just got to get rid of it. So I'm going to go to the health check, and then I'm going to also delete that, right? So in this case, I'm going to delete the health check. I'm going to go in and delete and confirm it, right? So confirm and then delete. Once that is done, my EC2 instances, I can also just get rid of them, right? So clean, terminate this one, the one in EU, US West, right? So delete this one. It's terminating. I'm also going to go to EU Central just to make sure I don't have any lingering machine running in there. So I'm going to terminate this one and terminate. Okay, cool. So that's a very nice introduction to Route 53. There's obviously more, but we'll continue to learn it as we progress. Um, we were looking at geoproximity, and we saw that, yeah, we saw what that means. We've seen health checks, right? We used a simple one. The fact that we created an health check, we just removed the security group, and immediately traffic just began to fail. After a while, there are like health checkers that will do all the health checks. You saw we had like a place we could enable the health checkers that we're going to use, okay? And you saw that once we enabled it, at some point they will do their own random health check. And if your instance is down, they're going to remove it out of the DNS answer, right? Remember, the DNS is different from the final query, right? Whatever is returned is what will tell the client where are you going to send this request to, right? So the details, at some point, we're going to be seeing them in details, but now we're just introducing ourselves to the subject. So CloudWatch integration is there. We just used HTTP as an example. HTTPS, there are so many protocols you can use. You can set up notification if you wanted to be notified if something was wrong. Obviously, there are also health checkers that are there. Route 3 resolver and DNS queries. Yeah, obviously, whenever you do, like, especially when I was doing like so internally in AWS, there you basically have resolvers, right? You can have resolvers. Resolvers are things that can actually tell you how do I resolve queries, right? So especially when you are especially within a VPN where for example, when you're inside a VPC where you're using a private hosted zone. The point is that all what we have seen is public hosted zone, right? Public hosted zone, but there's also private hosted zone, and for that, in most cases, you are trying to resolve private things, right? Things that are private within your network, and that's where Route 53 resolver comes in. So automatic resolution for AWS service names, right? So you can resolve anything that is private, right? Maybe an EC2 you want to be able to call EC2 instances with very clean names, right? Instead of reaching them via the IP address, right? You can also do that. This is really what brings to life if you now want to do hybrid. We've seen hybrid connection, but there's also hybrid DNS resolution also, right? Where you have that connection and now you want to resolve DNS. You want to be able to resolve private.onprem.com, or you want to resolve maybe cloud.private.com. Yeah, right. So two-way traffic. Maybe you're going to the AWS or going to the your private on-premise. Privately. Resolvers are the things that can help you do that, right? Conditional forwarding, DNS query logging. Yeah, you can all these queries that we're doing for the private resolvers. You can basically have like logs that logs all the DNS queries, right? Yeah, you can obviously connect your on-premise, so that means integration with on-premise DNS servers. So you can create that hybrid connection. I think for networking, we saw how you can connect and maybe send requests. What it takes to have that. But there will also be DNS. If you have some services, maybe your database is running in the cloud and the compute is running on-premise, or the vice versa, then there has to be that private connectivity, both in terms of the resources and also in terms of DNS, right? Yeah, for summary, DNS resolution basically translates domain names to your IP addresses. And we've seen that because what we actually had was IP addresses in our system, but we were able to open them, and we saw that this is a URL that opens on its own, right? And then we've been doing that up to this point. But today we actually saw what it took for us to have like a domain, right? Powering it. And then that domain is exposing traffic to the IP address, right? So we give a user tiktok.brainy.cloud, and when they open it, behind it is actually an EC2 instance, or it's a load balancer, or it's a global accelerator. Okay, so the point is that you should understand that everything that you see, every URL you go behind it, if you run a D command on top of it, there is really an IP address that is powering it. That's the only way to know what it's trying to get to, right? So Route 53 is now the service that we're using in AWS to provide that service, right? So manage DNS with global reach. AWS is obviously global, right? So we've seen different routing policies. We tried three. We started simple, multi-value, and then we tried geolocation, right? We saw health checks, how that can. We didn't really see failover, but it's the same. You have like a primary. You put an health check. If that health check fails, it basically switches traffic to the failover, right? Alias record, we didn't use any sample, but we could. We could still have TikTok, but cloud point to an AWS resource, which in this case, maybe like a load balancer, right? And private hosted zone is really, yeah, we played with public, but you can also have private. Private is basically VPC bound, right? Internal DNS traffic if you have those. Yeah, that brings us to the end of the class.